question, ma'am.
Hello, Dr. Sampurnam. Yeah, please go ahead.
Yeah, the thing is, as ma'am said, honey drops or it scales down anxiety symptom in TBI. What is the exact science behind it, ma'am? What honey contains and how does it drop anxiety level? Can you please explain the concept, ma'am?
I hope
Good
the question.
afternoon. I didn't really get the question.
What honey contains exactly to drop the anxiety level in TBI?
If I get you right, the question is, what is the science behind honey dropping the anxiety level in traumatic brain injury?
Yes, ma'am.
Okay, thank you very much. Well, it's actually due to the fact that honey, like I stated earlier in my presentation, honey has high level of antioxidants. Yes, and the one of the reasons of the anxiety-like behavior in rats, like I stated in my presentation as well, is due to the fact that neurons in areas that come, in the limbic system, that consists of the hippocampus, the amygdala, neurons in that area could get damaged. Even though those neurons in that area are not damaged, why I like the brain? The brain is a big ball of interconnectivity that allows fluidity of function. So no part of the brain stand on its own. That neurons, that axons are sent out, axons are sent in, they are interconnected. So even though neurons in that part of the brain are not damaged, peradventure, the connection of neurons from other parts of the brain to that part of the brain is damaged. Anxiety-like behavior can still be seen. So this is where honey comes in. For honey to be able to, prevent and protect against the neurodegeneration that would most likely occur either in the interconnectivity on the particular areas of the brain that is responsible for anxiety, for honey to be able to ameliorate that. That is to say that we can state that yes, honey reduces, the anxiety-like behavior of rats. I don't know if I did justice to that.
Thank you so much, ma'am.
Yeah, Dr. Sampurnam have got the answer. All right. Till the time we are having questions for Ms. Dennis, there's a question which we got from our social media, and we would like to have a small discussion on the same. The question is, what is the difference between coma and brain death? Yes, Dr. Adejoke.
All right, thank you. I think I'll say coma is a prolonged state of unconsciousness. Okay.
Yeah.
And that unconsciousness could be attributed to traumatic, maybe a higher degree of traumatic brain injury, stroke, brain tumor, or maybe even alcoholism. Some people, when they drink, they just kind of shut down their brain and they enter into the phase of coma.
Yeah.
And at times they even induce coma to reduce brain activity, kind of, if I can use that word. So, but brain dead, I think it's when like there's brain death, right? Or dead?
Yes. Brain dead.
Death.
Yes.
Okay, that's loss of brain function. Brain death is loss of brain function, and what is the essence of the brain? Is the neurons. So loss of brain functions, brain death can also be neuronal degeneration from my own point of view. as a researcher, I would say brain death is a loss of neuronal and neuron function. And it could be attributed to maybe a loss of blood to the brain, loss of oxygen to the brain, which is different from, it could be kind of similar to coma, because the cases that leads to coma has to do with loss of brain neural function. So that's how we explain that.
Yeah, this is a deep discussion. This is going to be a deep discussion then, because you have provided valid examples also. Thank you for taking the first step for the discussion, Dr. Adejoke.
Thank you.
Yeah, we would like to call anyone from all of you who would like to carry on with the discussion here. Come on, just provide your points or any example.
Okay.
The context. Yeah.
Okay,
Ms.
just to add to what Dr. Adejoke has said, I actually fully agree with her. Both conditions are actually associated with neurodegeneration, that is damage to the neurons. And when we say cell death, that is basically to say that that neuron or that cell is no longer functioning, it's no longer firing. There's nothing like action potential in that neuron. It is basically, in layman's terms, useless. So when you say someone is brain dead, that is to say each and every single one of that person's neuron is dead.
Yeah.
It is irreversible. You cannot do anything about it. But in a coma patient, yes, like Dr. Adejoke Memudu said, neurodegeneration is taking place. Yes, but there is still a fiery potential in certain neurons, if not all the neurons, just to an extent that it's not able to fully function. So yes, for a coma patient, there is hope of revival. There is hope that those neurons will function. There is hope that, the antioxidants in the brain can, restart, mop up the reactive oxygen species and all of that. But in a brain dead patient, there is no hope that any of that will happen because each and every single one of that person's neuron is dead.
Yeah.
Thank you very much.
Thank you for the points, Ms. Dennis. All right. Anyone else who would like to provide more points to it, to the discussion? Ms. Tanzia also added to the point, to the question in the chat box once. Ms. Tanzia, would you like to add on?
Is she on Zoom? Is she here?
Let me check. No.
Okay.
She's not here right now, but she provided an answer. Let me just
you can read it out.
You
can read that answer.
Yeah, I can read it. Or I was just going to post the answer in the chat box also. It's brain death. The kind of the same answer which Ms. Dennis has provided, that brain death is irreversible cessation of all functions of the entire brain, including the brain stem. A person who is brain dead is dead with no chance of revival. Coma, it is a state of profound unresponsiveness as a result of severe illness or brain injury. Yeah, this was the answer from Ms. Tanzia. Anyone else who would like to add on to the discussion?
Yes, I do have one more doubt.
Yeah, hello, Dr. Sampurnam. Yeah, please go ahead.
Yeah, the thing is, kindly let me know how they created brain injury for the rat. I would like to be, what to say, I would like to hear from the scientist.
You say what? How we induce?
TBI, yeah, injury.
Okay, we use there are different models. There are different models for inducing TBI
Okay.
in animal models. So we use the essence is to ensure that there's an injury to the brain. And traumatic brain injury in humans occurs due to laceration or deep cut wound. So how are we going to model that in animal? Is either you use a weight drop or you put a deep cut incision into the skull of the rat. So that's the model we use. Then afterwards, when there is process of neurodegeneration, there are biomarkers to show that neurodegenerative process is going on, which is leakage of some component of the cell membrane breakdown into the blood. So that's why we study malondihyde as a biomarker for oxidative stress. So in any animal model that induce a model of neurodegeneration, and there's an elevation of MDA, elevation of MDA symbolizing lipid peroxidation, that is indicated that there's oxidative stress in that animal. Then, but we didn't stop there. We now did tissue processing. Then in the processed tissue, staining for using H&E to see the histology of the brain tissue. Then Christopher's Valen to also see the nacelle substance in the cytoplasm of the neuron. We saw a characteristics of the histopathology reported in postmortem samples, which is characterized by loss of neurites, necrosis, loss of brain neuron cells. And if you look at it generally, it looks like a focal lesion in the frontal cortex sections and the prefrontal cortex. And those areas are the areas that connect with the limbic system to control fear and control mood and behavioral cognition. That has to do with memory, if you want to go to the extent of studying memory. But for us to now correlate this histopathology to behavior, because we are trying to answer the question that is there a correlation between traumatic brain injury and anxiety-like behavior or neurological disorder that can be shown in behaviors. We decided to use animal models. Now, because we can't go to subject and induce traumatic brain injury, we use animal models to report a signs. So there's a test, there's a behavioral despair test to show that anxiety, change of mood, sign of fear. Rats are exploratory animals, but when you put them in a space and the rats are, instead of them moving around, they're just enclosed in a corner, they're either scared because that thing is an elevated pulse, so the height is high, so they are afraid of falling. So we use that as part of the paradigm to measure their anxiety level to moving around the pulse maze. And in this model, the TBI model shows the characteristics. They were secluded. They stayed in the closed arm, away from the space to move around the four arms. They prefer to stay in the closed arm other than being in the open arm. Then the number of movements they made reduced as compared to the other animals. So that was what we used to report the behavioral changes as related to neurodegeneration being induced by TBI. Thank you. I hope I answered your question.
Thank you, ma'am. Very clear. Thank you.